Hello everyone, my name is Rahul and welcome to my channel DevOps Forge. Today, let's understand what are Terraform provisioners and what are different types of provisioners we have. So without wasting any time, let's get started. Terraform provisioners let you execute scripts during or after resource creation. They are useful for last mile configuration, but Terraform recommends avoiding them when possible because they break infrastructure as code practices. Okay, let's understand what provisioners are, their types, examples, and why they are considered as an anti pattern in the world of Terraform. So, again, what are Terraform provisioners? The provisioners let you execute scripts or commands on your local machine or on a remote server, okay? Or maybe if you want to copy some files to your infra, right? So the example workflow could be, let's say if you are creating a EC2 instance, right? And you want to run a script, an installation script onto that EC2 server. So let's say you want to install Flask on EC2 server, right? So you will use the provisioners and then you will be able to install the Flask onto that particular EC2 machine. So what it does, it will install your software, right? And they run after resource creation, which means whenever your EC2 will be created, then only it will run. Optionally, you can run it before deletion, and also it runs only once, which means it cannot be continuously managed, right? So like I said, here are some examples I have already prepared for you guys. So the local exec will run on local machine, correct? And remote exec will run on remote server, right? And file provisioner could be helpful when you want to copy some files onto your server. Maybe it can be your configuration file or maybe it can be your app file, right? So let's understand first local exec provisioner. So it will run commands onto your local system, not inside the resource you have created. Okay. So the example is over here. You have created a EC2 instance and then you want to, after that, you want to run a playbook. Okay. Deploy.yaml is the playbook which you want to run. So it could be helpful in these situation where you want to run um, any of the commands or any of the deploy or playbook or something like that. Then in that case, local exec provisioner is the best for you, right? And the use cases could be, let's say if you have deployed your application and after the application is deployed, you want to trigger a Slack notification, right? So first use case is this. Then let's say you want to update your inventory file. So suppose you have your Ansible playbooks, right? And after you create this particular EC2, you want to add this EC2 instance configuration into your inventory so that next time whenever you run any Ansible playbook, the this particular EC2 instance should exist inside this inventory. So it could be helpful in that case as well. Okay, you can call deployment script as well. Deployment script after this, and you can run CI/CD automation script, right? So for example, after your resource is created, your EC2 instance is created, what you want to do is you want to deploy a app, right? And in that case, after this resource is created from your local, you can deploy a script which can deploy your application, correct? Now here comes the remote exec provisioner where it runs commands inside the created resource via SSH, okay, or via WinRM. So suppose your EC2 instance is created and you want to do some installation, right? For example, you want to install Nginx. Then in that case, what will happen? It will particularly make a connection using the type SSH, and you will provide the user, your private key file, etc. And then in that case, what it will do? It will SSH into your instance and make a remote connection. and then it will install the particular updates or whatever you want to install, right? So in this case, remote execution is very helpful, and the use cases, like I said, it is very helpful to install some packages, right? It can configure services as well if you want to configure some kind of services. Then it can start your application, okay? And also you can use a bootstrap server as well, right? Now the next thing is you have a file provisioner, okay? Whenever you want to copy some important files or your application files or maybe some artifacts or supporting information to run your app, then in that case what you can do, you can copy file from your local machine to remote resource using the file provisioner, okay? And similarly, what you have used in remote exec, you can also use it over here. And what you can do is, we have provided connection over here. Similarly, you have to provide a connection and your private key so that the file provisioner can SSH into your VM, into your VM, right? The use cases could be you want to copy config files as discussed, okay? You want to upload some scripts which are required for the deployment or maybe for running your application or building your application, or maybe you have some cron scripts which you want to deploy or run into your machine, your remote machine, okay? Next thing is you can transfer any certificates which you want. This can also be considered as a useful use case, because SSL certificates are very necessary when it comes to a real world application, okay? And also you can deploy the artifacts by copying the artifacts into the remote machine, and then in that case what will happen, you will have your artifact files ready into your machine with the file provisioner, and you can deploy those artifacts, correct? Now provisioners can also run during destroy, and this is a advanced feature where provisioners can run before a resource deletion, right? So for that, an example could be provisioner local exec. This is how you define your resource. And then you will add a condition that when you want to run it, whenever you want to destroy a resource. And you can add a command over here. And let's say over here I am saying rm -rf star dot logs. So what I want to do is, as soon as my EC2 instance, okay, as soon as my EC2 instance is destroyed, I want to remove the logs file, okay, and I don't want anything inside that. So useful, the use cases could be your cleanup scripts, okay, and your backup triggers. Let's say whenever you want to delete a resource, you want a backup of some of the important files, and you have placed a trigger over here. So this can be helpful in that case also. So after your deletion, what will happen? The backup will trigger and it will back up all your important files and information. Okay, and I've taken an example of logging the deletion events, right? So even though these provisioners are useful, like we have seen over here, that local exec is also useful, remote exec is very useful, and file provisioner are also useful when it comes to copying your artifacts, important artifacts, or your SSL certificates, or your configuration files. So even though these provisioners are very useful, but why do you think that provisioners are considered an anti-pattern? Why? Because Terraform is basically designed for infrastructure provisioning, not configuration management. So provisioners introduces problems like non-idempotent. Okay, you can Google this. What is idempotent? And also, let's take an example where Ansible is idempotent. Okay, so learn about it. What is idempotent, and you will be easily you will be easily able to understand what is the concept and why anti-patterns exist in Terraform. Okay. Now, it may have some hidden dependencies as well. And it's very difficult to debug, right? It's very difficult to debug because if anything goes wrong, then you don't know like how to debug it inside your remote machine, or even if you are running a local provisioner, then the debugging could be very difficult because in that case, you are running the commands onto your local, and your real life um, logs or your real life errors or issues cannot be seen over there. Okay. Now, also, you have one more issue, which is the environments get inconsistent. Okay. And the automation could be fragile. Automation could be fragile, right? So let's understand the example issue where if a provisioner fails halfway, what will happen? Your infrastructure is created. Okay. If a provisioner fails halfway, infra is created. Okay. And configuration is incomplete, right? Your infra is created, but the configuration which you wanted to do over there is incomplete, and you have state inconsistency as well. Okay, so let's say you are relying on to a particular provisioner, let's say remote exec, and what you are doing is you are just installing some of the important applications or maybe some dependencies, and it fails halfway, right? It failed halfway, and what happened? Infra is created, but your configuration was incomplete, and you have automated all these steps using a CI/CD pipeline. Then in that case, if the configuration is incomplete, the next step in your CI/CD pipeline, right, in your CI/CD automation, the next stage would be requiring those configuration and you don't have it, then in that case your pipeline will fail and it will be a really difficult task to debug what actually happened. Okay, your state inconsistency is also there, and new Terraform cannot like safely recover. Okay, so what are the alternatives for it? Like, you are saying that provisioners are very bad and it is an anti-pattern in Terraform, then what are the alternatives? Okay, I can say this is also a best practice to use. So what you can do, you can use user data instance instead, sorry. Okay. So it basically runs at the time of instance bootstrap, which means whenever your instance is getting up, then only it runs. You can use cloud init. Okay. And the purpose is if you want to initialize the Linux, sorry. You can use Ansible, which is the best tool for config management. So this is considered the best tool in the market currently for configuration management. Okay. Now you can also have Docker, which will basically containerize your apps. Okay, cool. So the example of using user data instead of remote exec could be, let's say you created a resource. Okay. So I'm taking this example why it is better than remote exec, and you have defined your AWS instance over here. And what you do, you have also defined the resource name. Let's say the example is a resource name. You provide your AMI ID, okay? And you have provided your instance type, uh, something like t2.micro or t3.micro. And what you do, you provide a user data value where what you do is basically you add some configuration logic or some shell script, okay? You can add a shell script, right? And what you can do is you can say that apt update, okay, or maybe sudo apt install, and your whatever configuration you want to do, you can make in this shell script, and you can end this end of file, and you can close this, right? So this is a better option than using a remote exec, right? And we have understood why. Okay, so this user data will be much more cleaner, right? It can be also repeatable, and it is also production ready. Okay. So when provisioners are acceptable in real world, we must use provisioners only when no alternative exists, right? No alternative exists, then only we should use provisioners. Okay. You want a quick bootstrap of your resources. Okay. And if you think that your script is going to run only once, then only you should use the provisioners running one time scripts. One more thing is, if you want to trigger some external automation, then also provisioners could be helpful. Okay. And where you should avoid them, where you should avoid them, you should avoid them at the time of application deployment or config management. If you really want to uh, do the config management, then what you should use? You should use Ansible. Okay. And package at scale. Installation at scale. If you want to carry these things out, then you should not use the provisioners. Let's take an example code and understand how provisioners are used. So over here inside lecture 12 folder, I have a Python application. Okay. So I'm just creating an application where I'm just saying that, hello, welcome to my channel DevOps Forge, and I'm using Flask, and the host is 0.0.0 and the port is 18. Correct? The next thing which I have is the key pair file so that I can SSH into my instance. The other way is like this is the one way where I've created the file through AWS console and then I've stored it into my local. But you can also use SSH keygen to create your key pair file and then use it inside your main.tf file, your configuration file, so that you can SSH into your instance. Correct? Now let's create a main.tf file and I will say provider is AWS and region is US US East 1, right? I will just quickly spin up a simple instance resource AWS instance and I will keep the resource name as web server. Okay. So web server is the name and AMI ID. So as of now, I want to take an Ubuntu machine. So let's go over here. Let's launch this instance and go into the AMI images, right? It's loading. So this is the one I want to take, Ubuntu machine, and I'm just going to copy this AMI ID. Let's paste this over here. Next thing is what I want to do is I want to say that instance type would be t3.micro, correct? And the key name which we are going to use is Terraform examples dot examples only, right? So this is the one which we are going to use. Now let's quickly do one thing. I will say I will use a provisioner called file, and what I'm going to do over here is I am going to copy my application file into my remote machine. Okay. The source is app.py, right? Because it has in the source directory, we have it. The next thing I want to provide is destination, and the destination will be /home/ubuntu and /app.py. So it should copy this file over here. Next provisioner which I want to use is I want to use remote exec so that I will install some of the dependencies which are actually required to run my application. Correct? And for this, there's one important part which I want to mention is from newer updates, you cannot directly go and install Python packages or pip packages, right? So for that, what we need to do is we need to use virtual environment. Correct? So to use virtual environment, let's do one thing. I will add the inline commands. So inline means inline commands I'm going to add, which are going to run into my machine, my remote machine, after the resource is created. Okay. I will say sudo apt update and -y. So -y is basically what uh, it is an auto approval step, and it is widely used in automation, right? So it will not prompt the user to actually go and approve or say yes or no to update the packages. The other thing is sudo apt inside the quotes, sudo apt install. Okay, and I'm going to add the pip package. So pip is the package, and I have to add it while my virtual machine is activated. Okay, now next thing what I'm going to do is I am going to basically create a virtual environment, python 3 -m, and going to activate it as well, and home/ubuntu/vnv. Right, we have everything. Now what we want to do is we want to install Flask as well so that my application can run. Okay, so I'm going to add this inside bin and pip. Okay, so this is the command for it. Next thing is I think this is enough, and we'll go and SSH into our instance after the instance is created, and then start our application. Okay, so from where I'm using this command, actually I have this already with me, and I'm taking the reference from there, and I'm using these commands so that the packages get installed quickly. Now next thing, we have used remote exec, we have used file. The other thing I want to use is provisioner local exec, and over there I'm going to do a simple thing, which is what I'm going to run a command and say that echo, okay, echo ec2 public id is, and if I remember it correctly, it was self.public IP. Yeah, it was the one. So this will run locally and it will give me the public IP. And now what I want to do is to copy my file and to make the remote execution of all of these commands so that the dependencies got installed. I need to add a connection, right? We have seen in the example, the type will be SSH, it is auto completing. Next is user, and our user is Ubuntu, correct? Now private key, I will use the file command to use the file, right? We have seen this before, and the file name is, we know very well, Terraform examples. Okay, I must not mistype it. Examples.pm, PEM. Okay, I think it's correct. Terraform hyphen examples.pem. Cool. And the host is self.public IP, right? So the public IP of the instance will be used for SSHing into my instance. Okay. Now next thing is I'll do one more thing. I'll quickly add a tag and say that the name of my EC2 instance would be Flask app server. Cool. So we have every information. Okay. One thing we have missed over here is we need to add security group as well. Why? Because whenever you are trying to SSH into your instance, you need your 22 port to be open. And other thing is we are using port 80 over here, right? For our application. So to access our application, we need those ports to be open. So already what I have done over here is inside the default security group, if you go over here and inside this default security group, I have added the port 80, right, for HTTP and for SSH 22. The next thing what I'm going to do is I'm going to copy the security group ID and say security group IDs. Inside this string, I'm going to provide the value of the security group ID. Okay, now quickly initialize the backend. Let's wait for some time. So you understood very clearly that we don't we actually require security groups so that the Terraform or we can access to our application or run our application, and also the Terraform can SSH into your instance and copy the dependency files, copy your application file, and then also execute your application. Correct? Now we have 4 permission entries over here. All of them are there. If you use HTTPS, it would be fine. But since we are using port 80 inside our application, then we're going to use HTTP as our protocol. Okay, we are not going to use 443. I've just given this example how to add a port inside a security group. Now I think it is initialized. Next thing I'm going to do is I am going to apply the changes, and I don't want to get prompted in between for yes or no. So I'm going to use a flag called auto approve, right? And see, I have not been prompted to say yes or no to create my resources, and it is creating my resource. These are the information which I have, and one by one, what it will do, it will use these provisioners and execute this, and you'll be able to see all of that into the terminal itself. Okay, just waiting for that to happen. And yeah, the first step, it is provisioning the file, right? Now let's wait to web server be created, and I hope we didn't make any mistake. So we'll go through that once again. The file, we have providers, we have our EC2 instance, the AMID is correct, it seems to be correct, right? Okay, over here, see very clearly, you have some steps mentioned. So user is Ubuntu and password is false, right? We haven't used password. We were using private key, which is why private key value is true over here. And using that private key, the Terraform will be able to SSH into my instance. Okay. Now checking host key. So these are things which we don't require to understand. And inside the remote exec, you can see over here it is running. And inside this remote exec, all the commands which we have given over here is running. Okay, it is creating the virtual environment. Okay, it is updating the packages. It is installing pip, and it is also installing Flask. So these all executions are happening over here. Okay, let's go down and let's see the next step. Yeah, I think most of it is done, and local exec is also executed, and it says that EC2 public ID is 44.204.90.137, right? We have used this command to print, okay, echo EC2 public ID is, and you can see that clearly over here. Let's go to our console and match our ID, instance ID, okay? I will go to, okay, over here only, we'll go to instances. I will set the state to running, and yeah, Flask app server, this is the tag which we have added. It is up and running. Inside this, 44.204.90.137, and this is the exact same ID which we have seen in the terminal as well. Okay, now I will do one thing. I will actually connect to this instance using the instance connect. Okay, and let's run our application so that we can see it on our browser. So let's wait for till the time. Okay, connection is established. Now I'm going to run a command. Okay, sudo home Ubuntu. So inside the home, what I want to do is, while the virtual environment is activated, okay, I will run my app and I will say home Ubuntu app.py, right? So this is the command. Let's copy it because I want to show you one more thing. I've copied this and let's paste it over here. So you can see inside where we are, we are actually inside the home directory, and inside this, what we have app.py, right? And this is what we have provided inside our destination, that I want the app.py to be copied inside this folder, isn't it? So, which is why it is present over there. Now, quickly run our application and let's hope it's working. Okay, so the server is activated. Now, let's do one thing. I'm going to copy the public ID and let's say HTTP. Okay, yeah, you can see, hello, welcome to my channel DevOps Forge, and our application is active now. So this is how you use provisioners, and you can have different types of provisioners by which you can automate your deployments, or you can install some dependencies or some configurations. If you like this content, subscribe to my channel and we'll meet in the next video.